because it's
Yeah.
such a long period. I know that happens over the summer break. I never really thought about it too much over the Christmas break, but a month's a long time to go without doing the math.
We only have 2 weeks. College has a month.
Okay. All right, so we're doing inverses today.
Yeah.
Okay. Let's talk a moment about what an inverse is. A good definition of inverse is it is a function that undoes what an original function did. In other words, if I tell you we have a function y equals x squared, well, if I want to undo that, I've got to take square root of x. That undoes that. So the square root of x would be the inverse. So that's what inverses are. And they're also graphically, they are a reflection about the line y equal x. Every inverse is a reflection about that line. Okay?
All right.
All right, so that's what inverses are all about. Now, how we get an inverse is relatively simple and straightforward. How do I get an inverse here?
Do you just do the opposite things?
Well, not quite. That's the difficult way to do it. There's a real easy way to do it. It's 2 steps. First step, switch the variables. Second step, solve for y. Okay? So, first step, switching the variables. And now solve that equation for y and you'll have the inverse.
So it's just
Let's do it step by step. What's the next step?
it'd be x minus 5, or taking 5 from each side.
Okay.
And then dividing by -2.
That's the inverse.
All right.
Now, I could write that another way if you like. In other words, that's the same as 5 minus x all over a positive 2. That's maybe a slightly better looking answer, but this is certainly the same thing and the correct answer. So that's all we do, is we switch the variables and we solve for y. So, let's look at this one. Next line.
X equals 3y minus 3.
Next line.
X plus 3, then equals 3y, then divide everything by 3, so y equals x plus 3 over 3.
That's it. Now, it's very simple to do this when we're talking about linear equations, which all of these are. Okay? Not quite as simple when you start talking about quadratics. Once you introduce a quadratic, it becomes quite tricky. And I don't want to talk about it yet, but I would think in your honors class you'll end up having to do a quadratic on some of these. But maybe not. Rather than finish, I assume you have to do 16 through 32?
We only have to do 16 and 17 through 31 odds. We only have to do the odds.
Okay. So we've done 16 and 17. So we need to do 19, 21, 23, 25. Let's make sure we do one of these from this second section. And then we'll go back and finish the others if we have time. I don't want to run out of time before we get to these. Now, for one function to be the inverse of another function, something has to be true. What is it?
Do they have to be opposite?
No, there's one test to determine whether a function is an inverse of another function. And that test is f of g of x has to equal what?
G of f of x.
And they both have to equal x. In other words, also g of f of x has to also equal x. But equaling x is the trick. Okay? So, let's test this one. What is g of, or f of g of x equal to?
Do you just multiply, or
Let's do it step by step.
Well,
first of all, what would f of 2 be?
2x plus 14?
No.
No.
Go to the f function and plug in whatever's in the parentheses in for x.
So 9.
Okay. That's the way you handle whatever's in the parentheses, you plug in for x. So, when I say f of g of x, I'm really saying f of, well, g of x is that, so I'm really saying f of x minus 7. Now, what is f of x minus 7 equal to?
X squared.
No, you're going to plug in x minus 7 for x.
Oh.
In other words, the same rule. Whether it's a variable or a number, whatever is in the parentheses gets plugged in for x.
So, is it x minus 49?
No. In other words, I'm going to plug in x minus 7 for x, okay?
Alright.
Now I'm going to add 7.
Right, so just x.
That's what we're looking for. That's equal to x. So it passes that test. Now let's do the second test. Now, I've never seen one of these pass one test and fail the other, but let's do it. What is g of f of x equal to? G of what?
X plus 7.
Okay. And how do I solve that?
Just x plus 7 minus 7.
Which is equal to?
X.
Okay. So since f of g of x is equal to x and g of f of x is equal to x, that one is an inverse of the other. In other words, I can say that each of these are inverses of the other. That's the test it has to pass. Okay, let's try 27. I don't need to write it. What's f of g of x? Step by step.
So it's f, then 2x minus 2.
Okay. And maybe I do need to write it. F of x is equal to 1/2 x plus 1. Okay. So what's f of 2x minus 2?
So 1/2 parentheses x, or 2x minus 2 plus 1.
Simplify.
just x minus 1, so x, then plus 1, then x.
Okay. Now, did your teacher specify that you needed to do both tests, or is one sufficient?
You didn't really explain this very well, that's why I don't get it.
Let's do both tests. In other words, our g of f of x is equal to x, but let's look at g of f of x instead of f of g of x. So first of all, what's that equal to?
G of 1/2 x plus 1.
Okay. And g of x is 2x minus 2. So what is g of 1/2 x plus 1?
It's just x, it's,
Plugging it into that one right there.
alright, so it's 2x minus 2, then 1/2 x plus 1, then minus 2.
Simplify.
Just x plus 2 minus 2. Yeah.
They're inverses of one another. It's 29.
Alright, so it's just f of 3x cubed, or no, oh, x minus 1 over 3, so 1/3
And I
power.
need double parentheses here.
Oh,
Right? Well,
yeah.
Yeah, I do need double parentheses, absolutely. I can't do without the inside parentheses or the outside parentheses. And now, since f of x is equal to 3x cubed plus 1, what is this equal to?
It's 3 parentheses x minus 1 over 3 parentheses, or double parentheses that, then 1/3, or would it be the 1/3 power?
Yeah, excuse me.
Then the third plus 1.
Okay. Simplify, and how do I simplify that?
You could just, you could first simplify the exponents.
Well, what is the first step? What is the order of operations? Remember, order of operations is PEMDAS?
Yeah.
Well, a lot of times the P and the E can be reversed, and it's more proper to reverse them. So in this case, I'm not going to work from the inside parentheses. That would really complicate trying to find out what that function is to the 1/3 power. But notice that I can work from the outside parentheses just fine as the first step by multiplying the 3 times the 1/3. Clearly that's the way to go here, because what I end up with is the 3 times the 1/3 is 1, so I end up with that,
Yeah.
which is equal to x.
Alright.
Okay? And instead of doing the other half of that, which you may not have to even do, let's do 31. F of x equals x to the 5th plus 2 all over 7. G of x equals the 5th root of 7x minus 2. So f of g of x
is f of wait, it would be 5 the square root.
The 5th root.
5th root 7x minus 2.
So f of g of x is equal to what? In other words, plugging this into the f equation.
It would be the 5th root of 7x minus 2 to the 5th power plus 2 over 7.
Okay. Simplify that.
It would be just 7x over 7.
Equals x. Okay. Now, let's go back and look at the ones we didn't do. We didn't do 19. Find the inverse.
So x equals negative 4/5 y plus 11, and then x minus 11 equals negative 4/5 y,
Okay.
and then multiplied by the reciprocal, so it's 5/4.
Positive or negative?
Negative.
Yes. In other words, we want to multiply both sides by the reciprocal of that number, and the reciprocal of that number is negative. What's that leave on the right side?
Y.
And what's it leave on the left?
5/4 x minus
No.
plus 55/4.
Uh-huh. And there is your inverse function right there. Okay, let's look at 21.
Alright, so x equals negative 12y plus 7, x minus 7 equals negative 12y, then divide both sides by negative 12.
Now, there's your answer, and let's just talk about this briefly as to why I prefer this a different way. Notice that we've got two negative signs here. Well, x minus 7 is always equal to the negative of 7 minus x. A minus B is always equal to negative B minus A. So if I switch these two around, I got a negative 7 minus x. I'm dividing by a negative 12. The negatives cancel, and I end up with that, which still has a negative sign, but it doesn't have a negative sign outside of the parentheses. So personally, I prefer this answer, but I kind of doubt that it makes a difference with your teacher. I don't think she's going to take off points. I'm sure she wouldn't if you left it the other way.
All right.
Okay, 23 is really easy. Let me give you an example of one that is not so easy. Let's try this one.
Which be x equals y cubed, or y squared minus y minus 2.
Now, how do you solve that for y? Can't do it, can you?
No.
It's very hard. Very hard. Here's the tricky part. This is a quadratic. We can solve quadratics if one side is equal to 0. So I'm going to subtract x from both sides and get this. And I'm going to treat x as a constant. Now, that leaves 0 over there. How do I solve this quadratic? Using the quadratic formula and treating c as 2 plus x. In other words, the answer is going to be minus b, which is 1, plus or minus the square root of 1 minus 4 times 1 times c, which is 2 plus x, all over 2. And believe it or not, this is our inverse function. It's the only time in math I can think of where you're allowed to treat x as a constant, as a number.
All right.
Okay? So if you get quadratics as a test question, bonus question, or something like that, just treat x as if it was a number. By that I mean, if x was a number, let's say it was the number 4. Now I can solve this thing pretty easily, right?
Yeah.
Subtract 4 from both sides, I get y squared minus y minus 6 equals 0. I can solve it by factoring or using the quadratic formula. Well, let's say x is 5. Well, I could subtract 5 from both sides and then solve it. So no matter what x is, it's okay to treat it as a constant because my answer is going to have x in the answer. So it's still a variable. But it's quite tricky doing this, and like I said, I'm not positive you'll get one like this. But I thought I'd give you a heads up since I got a feeling you got these down pretty good now. Did we do all the ones you needed to do on the bottom? We did 29,
Yeah.
We did 31, we did all the odds.
Yep.
That should do it.
All right.
Okay? All right. My phone will be working by next time. We on Wednesday at 4?
I don't actually need twice a week.
Okay.
I should only need like the Monday.
Okay. So we'll remove the Wednesday and the Saturday.
Yeah. Then once we start getting into like way more complicated stuff.
Yeah, if it changes, you can always add sessions if you need to. So I will talk to you next Monday at 4.
Yeah.
All right, Mitch. Have a good week.
Thanks, you too.
Bye-bye.